Okay, so we're going to continue looking at our final section. We're going to look at quarks. Now, what are quarks? Remember we looked at three fundamental particles last time, and we focused on the gauge bosons. Now, quarks are the next we're going to have a look at. Okay. Now, this also hints at we're probably going to look at leptons next time, which is correct. But today we're going to focus on quarks. And quarks are really interesting. They have some really interesting names, and I'm not sure why they were named as they are, but I'm glad they were. All right, so there's six quarks, as you can see here. There is the up, and of course, if there's an up, there's a down. There's a top, and of course, if there's a top, there's a bottom. Then they also have charm and strange. I don't know, don't ask me. But yeah, those are the six quarks, and they're labeled using the first letter in the descriptor. So up is U, down is D, strange is S, all lowercase. So what's special about these things? The thing that's really special about them is they combine to form different particles. Okay. Now they combine to form different particles, but they can never be found in isolation. Okay. There's never just an up by itself, or a charm or a strange. Okay, they always come in pairs, and we're going to see actually pairs, threes, fours, and sometimes even fives. That was discovered just the other day. So these only ever come together, and let's have a closer look at them. So there's six types, as we've seen, and they all have different properties. So their mass is different, their charge is different, but basically they all have to have a plus 2/3 or a minus 1/3 charge. So let's have a look. So the up symbol U has a charge of 2/3, so plus 2/3. So we remember that a proton has plus 1. Okay, so this has 2/3 of a proton. The down has minus 1/3. Strange has minus 1/3. Charm plus 2/3. Top plus 2/3. Bottom minus 1/3. So you can see that's a similar pattern. Now you don't have to memorize this table. You will be provided it if necessary. But yeah, let's just think of these things as like it's very similar to protons and electrons, but they don't have the full charge. They've only got like a fraction of it. All right. So all matter that we know of, like atoms, are combinations of quarks and leptons. So again, remember quarks are what we're talking about now, and leptons are these other things we haven't seen yet. So combination of quarks and leptons. Now here's another word, baryons. Now these are composite particles, and they consist of a combination of 3 quarks. Okay, so if you've got 3 quarks, we call that a baryon, and these things include protons and neutrons. So question at this moment could be, what about electrons? Now if you had a look, if you were really clever, you would have seen that in our leptons, an electron is a lepton, okay? Which means it's not formed by quarks, it's its own individual fundamental particle. All right, so protons, neutrons, and electrons. Now these protons and neutrons are created from, if we remember, from quarks, okay? And if we remember, they're called baryons, and they're created from 3. Now, these are very special. The proton is created from an up, another up, and a down. So up, up, and a down. And a neutron is created from a down, and an up. So why does this matter? Let's have a look. So a proton is created from an up. We see here has a charge of 2 on 3, so 2/3, plus another up, plus a down, which is minus 1 on 3. Okay, if we remember from adding fractions, we add the numerator, so 2 plus 2, take away 1. 2 plus 2 is 4, take away 1 is 3, and the denominator is the same, so 3/3, which equals 1. So a proton has a charge of 1, which is correct, plus 1. And a neutron is a down, down, and an up. So minus 1 on 3 plus minus 1 on 3 plus 2 over 3. So negative a third is negative 2/3 plus positive 2/3 equals 0/3, which is 0. So a neutron is neutral. All right, so that's how these things work, and there's a lot of different combinations you can have, but proton and neutron are the most common. An electron, you might be asking what combination makes up an electron, but we remember this is a lepton. Okay, so what we're going to write is this is a lepton. Right, so it's not a combination of quarks. Okay, that's all we were going to look at today. Thank you.